Good morning, students. Today, let us start the AI lab with week 1 program. That is, write a program to implement uninformed search techniques, that is BFS and DFS. We already discussed the theory concepts of this breadth first search and depth first search. So, if you still have doubt, once again, you listen to the algorithms explanation of videos, this BFS and DFS. So coming to the BFS, the very first step is the initialization. Here, generally we'll have two main structures. One is visited list and one is the queue. This visited list is to keep track of nodes what we have visited, and queue helps process nodes level by level in BFS. I hope you remember in BFS we are going to traverse the graphs level by level. And this is the very first step is first we need to create a graph. So for that we have used an adjacency dictionary. You know that this is a representation of a dictionary, which is we are going to have a key and value pairs. So here, if you take this graph, A is connected to B, C, D, and B is connected to A, C is connected to A, and parallelly it is also connected to D, and D is connected to A, C, and E. E is connected to D. So in this way, we are going to define a graph with the help of a dictionary. And then we are going to start with the BFS function where we are in the function BFS. We have three arguments. One is visited, graph, and node. The first node here A, and for that before that we need to create two empty lists, which is visited and queue. Okay, and when we explore the node A, it is added to the visited list, and at the same time it's also appended to the queue. Now we are going to define a function. We know that in Python how we are going to define a function with the help of a keyword called as def. So def, the function name is BFS, and we are passing three arguments: visited, graph, and node. This is visited is already here. Graph here we have defined, and one more argument we have added is node. So BFS next one is how we are going to processing the queue. BFS works by processing nodes in the queue while the queue is not empty. Okay, we keep removing nodes from the front of the queue and then explore their neighbors. That is, whenever we visit one node, it is going to be marked as visited, and at the same time, it is also added to the queue. So once we visited one node, okay, that node is appended to the visited list, and at the same time it is also appended to the queue list. And while queue is not empty, okay, here we are going to remove the front vertex or vertex at the 0th index from the queue, and then we are going to print that vertex. So here we are popping and simply we are printing that node. And then this piece of code here for neighbor in graph of V, here it is iterating over neighbors and checking if the neighbor is visited or not visited. And if it is not in visited, then marking the neighbor as visited, and the same time we are adding that neighbor to the queue. So this neighbor, whatever is iterating over the graph, and if neighbor is not in visited, then we have to mark it as visited, and then at the same time we are going to append to the queue. Then we are running the function visited graph with a node A. So here when we run this piece of code, that BFS visited graph A, initially A is added to the visited list, and at the same time it is added to the queue. And BFS removes A from the queue, and its process it neighbors B, C, D. And these neighbors B, C, D are marked as visited, and at the same time it is going to add it to a queue. So in this way, this process continues until all reachable nodes are visited. And at the same time, it's popped from the queue. So this is how the breadth first search algorithm works. So you draw a graph, or else you take another graph with another variables and try whether our theoretically how we are exploring the BFS node in the same way it's exploring or not. Once again, you check with the different nodes or different graphs. See, this is the piece of code. what I explained part by part. This is a piece of code. So we are creating a graph, then queue and a visited list. Then we are calling a function, sorry, defining a function. Then marking node as visited and adding to the queue. And when this popping out that and iterating over the neighbors and not visited, appending and visited to the queue list. Then we are calling the function BFS with these three arguments. This is the piece of code how we are going to run breadth first search algorithm in Python. Next, let us see the depth first search algorithm. Here also, first we are going to create a graph with an adjacency list. This is how we are representing the graph. So here we know that 5 is connected to 3 and 7, 3 is connected to 2 and 4, 7 is connected to 8, and 2 and 8 have no neighbors, and 4 is connected to 8. In this way, I have defined one graph with the help of a dictionary. Next, I am creating one set. Okay, this to keep track of visited nodes, I am using the set, and that I have assigned to a variable called as visited. So why we are using this set is to ensure that there are no duplicates. For that, we are using this set. Then we are defining DFS function. Okay, that to implement DFS, we are defining one function with 3 nodes, same visited, graph, and node. Just checking if the node is not already visited, then we are going to print the node. If it is not visited, just it is going to print the node, and that we are going to mark it as visited by adding it to the visited list, visited set here. Okay, and this loop iterates over each neighbor of the current node, and this DFS recursively calls on each of the nodes neighbors. Okay, each of these neighbors also it is going to call recursively. So this algorithm starts the process of exploring all the neighbors of this particular neighbor, and this DFS explores as far as possible each branch before backtracking. Before backtracking, at one depth it is going to explore all the nodes. Okay, so to print how this DFS, here you see we are calling the DFS function with three values, one visited, graph, and I'm starting node we have given 5. So starting from 5, first it visits 3, then explores 3 neighbors, that is 2 and 4, followed by n. And after exploring this 3, it backtracks to 5 and proceeds to visit 7. Means one depth it traveled and explored all the nodes, and it backtracked to the root node, and other side it is going to traverse. So for the particular graph what we have given, so this is the depth first search algorithm traversing of the graph. So 5, 3, 2, 4, 8, 7. So theoretically you draw that particular diagram and check we are getting the same output or not. Thank you. So this is the piece of code what I have explained. So you can check it. Graph, visited list, iteration over this, and then printing the graph. So this is how DFS and BFS can be implemented with the help of Python.